Okay. So, if able to recollect what we discussed in the last lecture. In the last lecture, we're trying to understand, we're trying to conclude the concept of libraries, where the static libraries will help, where the dynamic libraries will help. In a cross compiler environment, where you are writing the program and dumping into the microcontroller, for writing the program, we might have used some cross compilers. In such case, the cross compiler's job is to create one hex file. In that hex file, everything should be present. In such cases, dynamic libraries are not preferable. The static libraries are preferable. Why? Because when we are dumping our program into microcontroller, we didn't bother about what are the supporting files we need to dump. Just we need to select the hex file and we'll dump that hex file into the microcontroller. So in such case, static libraries will help us compared to dynamic library. In operating system environment, if my application is running on the top of the OS, so in such case, to utilize the RAM space effectively, so we need to go for, to utilize the RAM space effectively, we need to go for, can you type the answer? Static library or dynamic library? We need to go for static library or dynamic library? Dynamic library. And also, we need to go for dynamic runtime linking concept compared to load time linking. The disadvantage of load time linking is, if my application required 100 libraries, if my application is loaded, all those 100 libraries are also loaded. But as you know that we are not going to call the functions immediately which are present in those libraries at a time. In such cases, we'll feel that the library is occupying unnecessary RAM space. To overcome that, we need to go for dynamic runtime linking. In this runtime linking, entirely the different procedure is there to call the function. Entire different way is there to call the function. Till now, we call the functions directly with the function name. To achieve the dynamic library, to achieve the dynamic runtime linking, we need to call the function using function pointer. So for that, we need to approach a different method. We need to take the help of some is there a disturbance in my volume? Is there a disturbance in my volume? No. V4, try to check from your side. So in such cases, we need to go for dynamic runtime linking. So we need to follow some procedure for this. We can't call the function directly. First, we need to open a library whenever we require, and we need to get the function address. Then we need to call. This is a little bit time taking process. So we can say that dynamic runtime linking, calling the function via dynamic runtime linking, is slower compared to the load time or compile time linking. Will you agree the statement? Again, I'll repeat the statement. When I am calling the function, so which one is a faster means, in which method the function is called faster means, maybe it is a static linking, compile time or load time linking. Because before my program execution, if the addresses are resolved, before my program execution, if the addresses is resolved, at runtime we no need to worry about the function address, getting the function address. But advantage is there, but disadvantage is also there. So those things we are trying to understand in the last lecture. After conclusion of this, so can we say static library has its own significance, its own importance, and dynamic library has its own significance, its own importance? Again, can we say static library has its own importance and significance, and a dynamic library has its own importance and its significance? Hmm? Okay then. So after that, we started thinking about the another module, the topic which we are going to, actual topic which we are going to discuss in this, that is operating system concepts with Linux environment. So in this, what are the topics we are going to discuss? Main module topic names I mentioned it. process and process management, signal handling, file management, IPC mechanisms, process synchronization using a semaphore. Like this, these are the main topics. Shell scripting. These are the main topics which we are going to discuss in this next few days. And in this, the very important topic to understand the entire Linux system programming, that is nothing but process and process management. And here, 30% of the theory concepts will be there, and 70% of the programs will be there. Again, the programming involvement will be there. As I told you, in the day one onwards of the embedded system course only, I told you to prepare yourself for writing the programs. In all the modules, entire embedded system modules, the programming involvement will be there. And after that, we started thinking about these points. What is an operating system? Why an operating system in embedded system? Why especially Linux operating system? What are the components of Linux operating system? And the booting steps of Linux OS. Starting with process and process management. Before starting with this process and process management, beginner, you must and should know why we are learning all these concepts. Beginner, you should know what is the need of embedded engineer should have the concept of this. So that is the today's aim, today's discussion. And in the last lecture only, I'm trying to explain you in a simple way, in a very basic way, what is an operating system. One point I asked you, very straightforward question: is an operating system is a hardware and or software? All of you told that operating system is not a hardware. Operating system is a software which is managing the hardware. Can I say operating system is a software which is managing the hardware? Operating system, in a simple one word answer, I can say operating system is a resource manager. Now tell me, what is the meaning of resources here with respect to operating system terminology? What is the meaning of resources? Answer is resources is nothing but the hardware modules, like keyboard, like mouse, like webcam, like what you called hard disk, RAM, processor, whatever the hardware components. Will you agree the laptop or the desktop, it is a combination of different hardwares? Will you agree the laptop or the desktop, it is a assembling of all the different components. Hmm? Assembling of all the display all the things. So to manage all these resources, there should be one responsible person to manage all these resources. Again, to manage all these resources, there should be one responsible person on the top of this hardware, that is nothing but OS. Operating system is a resource manager. Operating system is a, if you see one more definition, an operating system is a program. Observe this point. An operating system is a program that manages the the operating system is a program that manages the computer hardware. It will its responsibility, its main responsibility is to manage the hardware. It acts as, if you observe this point, it acts as uh, intermediary between the computer user. It acts as intermediary between the computer user and computer hardware. Again, it acts as intermediate between the computer user and the hardware. Non technically, we can say OS is a mediator between the user and hardware. Again, non technical definition, in a simple definition, what is a OS is? OS is a mediator between the user and the hardware. Technically, we should not say this definition. Technically, we need to say OS is a resource allocator. OS is a resource manager. Now, can anybody tell me who need the resources? I told you OS is a resource allocator or OS is a resource manager. Can you tell me who need the resources? Answer is very simple. User need the resources. Will you agree? We need. You're using the laptop, so you need all these resources. You're using the desktop, you need this all the resources. You're using the mobile phone, will you agree? You need, means can I say user need all the resources, user need all the hardware. If we take an example, if you want to if you want to create one document, now tell me which application you will use. If you want to create one, if you want to write some notes in a laptop, can you tell me which application you will use? If you want to observe, this is a notepad, right? In this notepad you'll try to note the word notepad or whatever it is. Now for typing, which hardware you will use? For typing purpose, which hardware you will use? Keyboard. Whatever you are typing, to see which hardware you will use. Observe, if you I'm writing here, so how I am able to see this letters? Through monitor screen. And whatever, if I save it, can you tell me where this file is stored? In a hard disk. If you logically think here, three hardware's involvement will be there whenever I am writing the file, whenever I am writing a notes. One is keyboard for writing purpose, another one is what you called a screen for display purpose, and another one is hard disk for saving purpose. Internally RAM involvement will be there. Internally RAM involvement will be there. Why? Because when I double click this application, observe, when I double click this notepad application, can I say this application started running? Can I say this application started running? When I double click this application, will you agree? This application is loaded from hard disk to RAM. Will you agree? This application is loaded from hard disk to RAM. So RAM involvement will be there. Without RAM involvement, nothing happens here. One of the student video is on. Please check it out and switch off it. So, so very basic definition of OS. OS is a program that manages all the hardware. OS is intermediary between the user and computer hardware. OS provides the services for running application and computer system. Running applications. Applications. We are using all these applications. Now, can you tell me, in my system, by seeing this screen, can you tell me which are the applications are running now? By seeing this screen, can you tell me which are the applications are running? One is, I'll annotate it. One is, this is running, this is running, this is running, this is running, this is running. Will you agree? These are the running applications. I didn't open the terminal, but these are the running applications. So OS is a manager which is managing all these resources, which is managing all these resources. Zoom is also running, correct? Perfect. Without Zoom, we can't. You are unable to see the screen, right? But will you agree? I'm not using the voice from this my laptop, because some issues are there in this my hardware. That is the reason I'm not using for voice purpose. I'm not using this my laptop for voice purpose. I'm using for clarity purpose. I'm using my mobile phone. So like this, who is responsible for managing all these resources? Answer is very simple. Answer is very simple. OS. Now tell me, in my laptop, if OS is not there, am I able to use this? Am I able to use these applications? Am I able to use these applications? No. One of your friend is asking, can we use a word device hardware except expect to computer hardware? I don't know what's your question. S16. Hardware should, and one more thing, on that day I told you in the last lecture, nowadays the embedded products are coming with nowadays the embedded products are coming with inbuilt OS. Now the second point we need to discuss, why operating system in embedded systems. As all of you know, the definition of embedded system is a combination of hardware and software. Will you agree? The definition of an embedded system is the combination of and hardware and software. One of your friend is asking, sir, how internal GPS works in car without internet? So M19 unnecessarily the topic is going to divert so that you can communicate once the microcontroller starts. One of your friend question is how internally GPS works in car without a internet. That is a unrelated topic for the time being. Second thing is, sir, OS is only for running applications. Running applications means yes, definitely. If I am not using any application, there is no involvement of OS there. If I'm not running any application, there is no involvement of OS there. Yes, sir. But background, there are so many other applications are running. Those are called as a daemon processes. Background, there are so many others are running. Now, if you take an example, Wi-Fi, yes or no? Internet for internet connection. Background, there may be a one application which is continuously running for scanning your system. So don't think that applications running means the applications which you are using. Background, there may be so many other applications which are running without your knowledge. H1 is asking where we place the OS in embedded product. Observe. Embedded system is a combination of hardware and software, and embedded system is a combination of. Will you agree? Embedded system is a combination of controllers, sensors, interfaces, so many things. Embedded product is a combination of controllers, sensors, and everything. Huh? It performs a given task more effectively with completely or partially depend on human interference. If you see this point, embedded system is a combination of some controllers, sensors, some interfaces, etc. etc. So many devices will be there to perform a given task more effectively with completely or partially independent of human interference. Means some of the embedded products there is no human interference, and some of the embedded products which partially human interference will be there. And observe this point, very important. Today, embedded systems are capable of multitasking. Will you agree? Today, embedded systems are capable of multitasking. Multitasking means multiple works can do, and they are able to take decisions in a real-time environment. Today, embedded systems are capable of multitasking, and they are able to take decisions in a real-time environment. Will you accept this statement type 1? Will you accept the if you accept this statement type 1? Today, embedded systems are capable of multitasking, and they are capable of taking a decisions in a real-time environment. All this is possible. All these things are possible because of nowadays embedded systems are using operating system in their software part. Observe this point. Observe the last point. How multitasking possible? How in a real-time environment it will means uh, all these are possible because nowadays embedded systems are using operating system as a software part. Operating system as a software part. One of your friend is asking V19, B8, A18, where is operating system is placed in a embedded system. Now, where is operating system is placed in embedded system. Now, tell me in your laptop, where is operating system is there? Now tell me in your laptop, where is an operating system is there? A18. You might have installed the OS, right? Where is OS is present? Will you agree? On hard disk and a permanent device. Similarly, whatever the embedded product you are using, there first you need to load an OS. On the top of the OS, the applications are going to run. Whatever the applications are there. Got the point? A18. Got the point? So, previous days where embedded system can perform only one task, in a previous days embedded system can perform only one task. So directly you are loading one program into microcontroller without OS. Example 8051, where directly your program is going to load it and only that program will run. But nowadays the smart embedded products are coming where which can perform multitasking and concurrently, not a sequentially, concurrently. We need to understand what is a sequential, what is a concurrent. There are so many things are there we need to. So in such case, what is your job is, first you need to install the OS. First you need to load an OS on the top of the hardware. On the top of the OS, the applications are going to run. The applications you are specific. Like if you take a router, can you tell me what is the job of the router? In our office, we are using one router. We have an internet connection. We have Airtel connection or Act internet. Now, what is the job of the router? Providing an internet. Who will install this router to our premises? Who will install this router to our premises? Can I say internet service provider, ISP? Yes or no? For them, we are charging every month. Service providers. So nowadays, what are the routers are coming? Will you agree? Nowadays, what are the routers are coming? Will you agree? Those routers, wired and wireless, means you can communicate through router wired as well as wireless. Will you agree? If you see the router, backside some ports will be there where Ethernet port will be there. You can communicate wired as well as wireless also. Will you accept this statement? And A18 is asking one question. Approximately how much memory required to OS? A18 is asking one question. Approximately how much of memory required to OS? My answer is in embedded depends upon your requirement, depends upon your configuration. Now my request to everyone, in your smartphones, OS will be there. Check it out. How much of space your OS is occupying? Is it possible? Is it possible to check in your mobile phone how much of OS is occupying the space? It's not fixed. Depends upon the OS. Depends upon what you called your mobile phone and version and so many other things. Similarly, in your embedded product, depends upon your specific task, depends upon your requirement. You need to configure the OS. That is the benefit of Linux OS. Will you agree? You need to configure depends upon your requirement, depends upon your specifications, and you can load it into your microcontroller. B1, don't worry now. B1 is asking, sir, OS is loaded into hardware or some space in our RAM also? B1, you are going to get the clarity today. You are going to get the clarity today. Can anybody tell me uh, in your mobile phone where the OS is present? In your mobile phone where the OS is present first? Internal storage. Listen, permanent storage, can I say? Permanent storage, can I say? When you switch on the mobile phone, will you agree? It is loaded from there to when you switch on the mobile phone, that OS is loaded. Today we need to understand the booting steps also. I told you today's discussion is we need to understand the booting steps when you switch on the system to login screen comes, what is the background happening, that we need to discuss it in a generalized way. I hope all of you are getting the points what we are going to discuss it. So nowadays, now I'm talking about a router, right? In a router also, in a router also, OS will be there. Now, when OS is present in this embedded product, then what happens is it can perform multiple works. When OS is present in an embedded system, it can perform multiple works. Is it clear? Without OS, only one while one will can run, but with OS, multiple while ones can run. What is the meaning of while one? Why I use the term called while one? Because already you know the C program, already you know the programming. So while one means this is one task. Suppose this is one task. This is another task. Like this, multiple while ones will run. Now logically think, to my router, three devices are connected. This is my router. Three devices are connected. Can I say these three devices are capable of communicating in internet? Now in this router, there should be some responsible person to manage all these things. I don't know, you know it or not. In a router, there are so many what you call protocols will be there. Routing information protocol, OSPF protocol. So like this, there are so many applications are running on the top of the OS, continuously working in a while one. Now one more thing I need to tell you for freshers, in single day, entire thing imagination is very difficult, very tough, and also you don't think entire thing in a single day. And also in the first day of our Linux system programming. Will you agree? In a single day, understanding the entire concept, understanding the entire OS, and writing the programs on the top of the OS, it's very difficult. As all of you know that we are going to learn one concept called Linux system programming. And I told you there are some layers will be there. One is application programming, one is a system programming, and another one is a kernel programming, and another one is a driver programming. Like this, some layers will be there. I am not saying that your questions are invalid. I am saying that your questions are valid. 100% your questions are correct. But some of the questions I cannot explain at this moment, because if I keep on explaining those type of answers at this moment, unnecessary topic is gets diverted. Unnecessary so many confusions will be there. So I'm going to take this system programming very systematically, very step by step. Otherwise, lots of things will be there. Lots of confusions will be there. Got the point? All of you got the point? When the time comes, we'll discuss that point. Okay. Now let's move to this things. So nowadays, all the embedded products, very simple. Tell me, very simple thing. Tell me in a normal general thing. There are three devices are there: device 1, device 2, device 3. Three different purposes. There is one device came into the market, a new device which can perform these three device works. There is one new device came into the market. New device is launched into the market. New device is introduced into the market which can perform these three devices works. Which can perform these three devices works. Now tell me which one you will prefer in that case. Device 1, device 2, device 3 separately you will purchase, or only device 4 you will purchase. In a internet or in a social media somewhere sometime, one photo came. I don't know you know it or not. In an office, What are the different devices are there? Your mobile phone is replaced with that. Listen, for taking the picture, for taking the picture. So just we previously we used a camera. Now that camera is there in your mobile phone. For listening the song, for alarm, for calendar. See, so there are so many things where one device can perform. Now obviously the customer, the end user will agree it will prefer this device compared to purchasing individual three devices. Now this device can perform these three devices works means, can I say in this device three programs should run? As an embedded engineer, you can imagine now. In this device, these three programs should run concurrently. Three while ones should run. And there are so many resources, like if you take your mobile phone, camera is there, touchpad is there, Wi-Fi module is there. I told you in the last lecture, I told you to list out the devices, sensors or modules which are present in your what you call in your mobile phone. And one of the benefit of operating system loading into this device is one device can be used for multiple purposes. Like on that day I asked you, when you went to a shop and you need to pay the amount online, whatever it is there, Google Pay or whatever it is. So then what you will use? Then you told that I'll open the application. In that application, I'll use the scanning. So when you use the scanning, can I say that application internally uses the camera, but camera is normally used for taking the pictures. But I can use the camera as a barcode scanner. I can use the camera as a gesture sensor. So one device can be used for multiple purposes. How it is possible? Answer is only when responsible manager is there on the top of the hardware, which is managing all these resources. That is nothing but operating system. So nowadays, the customer, the end user choice is he want one product which can perform a multitask. Again, nowadays the end user choice is the customer wants one product which can perform a multitask. So as an embedded engineer, our job is we need to we need to what you call develop one device which can perform a multiple tasks. So there should be so many sensors, there are so many interfaces will be there. So what your job is, you need to first load an OS on the top of that. So 50% of work is finished, because OS is a resource manager which can manage all the resources. I hope this point is clear. All this is possible. I hope this point is clear. All these things are possible nowadays. In embedded systems are using operating system as their software part. Now the question arises, which OS? Now the question arises, which OS? Now the question arises, which OS? A18, please try to wait. On the top of the controller means every, see in your like in your, tell me, in my laptop one processor is there, or controller. Don't think about what is the difference between the processor and controller nowadays. Now, right now, once the Pramod starts 8051, definitely sir will discuss the processor and controller difference. Now, when I switch on the system, will you agree first OS is loaded? When I switch on the system, first OS is loaded. After that only I can use these applications. After that only you can use these applications. So and similarly, when you switch on the router, internally OS is going to be loaded. Then only that applications starts running background. Listen, like, so now the discussion is, now all of you able to imagine, without OS if I design one product, with OS if I design one product, which product is having high demand? Again, all of you able to understand the point. Without OS if I develop one product, With OS, if I develop one product, so which is having a more demand? Answer is with OS is having a more demand. Why? Because of OS, all the resources are managed properly. All the resources are what you call allocated properly. So performance is high compared to without OS, and it can perform multitasking also. You may get a doubt, sir, without OS, is the multitasking cannot be possible? Answer is, it can be possible up to certain extent if somebody knows about the concept of interrupt. Again, if somebody may have the doubt, sir, without an OS, is the multitasking is not possible? Answer is, answer is yes, I can say, but up to certain extent. What is that certain extent? Observe. This is little bit high end, but you can understand. Suppose this is a while one. OS is a set of programs. Definitely B1 is correct. OS is not a one program, it is a set of thousands of programs. This is a while one. I'm talking about without OS, I'm not talking about with OS. Observe, this is a while one. Multitasking is possible. Can I say it is performing task one? Will you agree it is performing task one? Imagine it. Without OS, how the multitasking is possible means when this application is running, there should be a concept called interrupt. You need to interrupt this. So it will go to the ISR. In that ISR, you can write a task 2. It can perform this task 2. Again, it will come back and it will run the remaining portion. Multitasking is possible, but now try to imagine when the task 2 is running, task 1 cannot run. Will you agree? When the task 2 is running, task 1 cannot run. Hmm? So without OS is possible up to certain extent. But with OS it becomes very easy. This while one and this while one, both task 1 while one, task 2 while one will run. You may get it out how it will run. It will take around at least 1 week of time to understand a little bit clarity. There is a process manager which will manage the processes. Time slice will be there. There are so many things will be there. It will take some time to understand that. So if somebody asks in an interview, without an OS, is the multitasking is not possible? What will be your answer? Without an OS, is the multitasking is not possible or possible? What is the answer? Answer is possible, but not effectively. Answer is possible by using the interrupt mechanism. But one thing is, when task 1 is running, when interrupt comes, task 1 is suspended and that task 2 will run, and after completion of task 2 only task 1 will run. At a time only one task will run, correct? Okay, then now the discussion is, as an embedded engineer, you decided that, as a startup, you decided that I need to design one creative product, very interesting product. This product can perform multiple works: W1, W2, W3, W4, W5, like this. Again, I need to design one product which can perform these many works. Embedded product. Embedded product means, will you agree, hardware will be there, software will be there. Embedded product means, will you agree, hardware will be there, software will be there. Yes. Now you tell me, if you want to design an embedded product which can perform these works, so better option is, in this embedded product, first you load a OS. Load an OS. The first question arises, which OS? Which is suitable for this particular things? Which OS? Answer is very simple. You can go for a Linux OS. Why Linux operating system? The first and very important point about the Linux OS is, it is an open source in nature. Open source means it is an open source in nature. Open source means it is a free of cost, no license. You can go to the linux.org. You can download the latest kernel version. Observe, you can go to the linux.org and you can download the latest kernel version. Somewhere it will be there. Somewhere I am unable to, but somewhere you can download it. Anybody can access, correct? Latest version you can access it. Anybody can access it. Anybody. It is not a licensed one. There is no proprietorship. I think kernel.org. Just a minute. Kernel.org. There is no proprietorship. See, latest kernel version is 5.9.14. All of you able to see this? Latest kernel version is, what is the kernel? We need to understand. All of you are observing? The latest kernel version is 5.9.14. It is a free source code. It is a community. Heart of the OS is a kernel, correct? So let's come to this topic. So I, as a startup company, I have a new idea, I have a new innovation, I have new thoughts. I need to design one embedded product which can perform these many tasks. So I decided that I need to load an OS into this so that handling these resources becomes an easy. Now the question arises, which OS? We are talking about Linux OS. Why Linux OS? One of the plus point about the Linux OS, one of the important plus point about the Linux OS, open source in nature. Open source in nature. Open source means you can download the Linux source code from line number 1 to line number n. How many lines are there? How many files are there? You can open, you can read it. Is that point is clear? And it also secure. Compared to other operating systems, Linux is more secure because of some internal architecture, because of some internal points. It is permissions and virus. Yes, in a simple way, we can say virus free. There are so many things are there. Why it is called as a virus free and all other things? Again, single date is not possible to imagine for you to entire thing. One of your friend is asking how to say Linux is a secure because free source code. See, R3, my point is, in your microcontroller or microprocessor, in your embedded product, you are not loading the source code, right? You are not loading the source code, right? You need to configure that, depends upon your requirement. You can add some additional features. You can enhance it, you can put it. There is no relation, there is no link. One of your friend is saying, asking that, sir, it is an open source, how it becomes a secure? Security not in terms of program. Security is not in terms of program. Got the point? Everyone can see the program. Security in terms of your data. Is it clear? There are so many permissions will be there in a low level kernel level. There are so many security filters, security things will be there. Because of that, we can say compared to other operating systems, it is a more secure. Open means we can add features. Yes, we can add features. If you don't want, we can. If you don't want, we can. If you don't want, we can. What we can? We can delete some of the features. Like this, whatever the things are there, you can do it. Observe. One more thing is, it is an open source, it is a secured, can revive in older computers also. What is the meaning of can revive in older computers? One thing I need to tell you, Windows operating system can be loaded in Intel related family processors and ARM processors. But tell me, when you are designing your own product, is it mandatory that you need to use these two processors only? This much high-end processors, this much high configuration, high performance processors? No. If that is the case, if that is the case, so I can choose any small processor or controller. I can load OS onto that Linux OS. I can load it. So meaning is Linux operating system can be loaded around 25 to 30 different hardwares. Linux operating system can run around different Linux operating systems can run around 25 to 30 different microprocessors or microcontrollers. Now, can you tell me, in your laptop which processor is there, and in your mobile phone which processor is there? Whatever it is. But it Linux operating system, the main advantage of the Linux OS is, so it can be processed, it can be loaded into different small microprocessors or microcontrollers also, with minimum specifications it will work. Got the point? It's not a compulsion that when you're designing you need to use AMD only, you need to use what you call Intel only, you need to use ARM only. Got this point? Different hardware architectures, you can use it. Perfect for programmers. You are passionate about the programming, so Linux environment is perfect compared to other environments. Customization. As I told you, customization means what are the things you need, you can take it. What are the things you don't want, you can delete it, and you can configure it, you can modify it as per your requirement, you can use it. Now, there is very simple way to understand what is the difference between the general purpose OS and embedded OS. Now tell me, in my laptop, in your laptop, or in it is a general purpose OS. And whereas for this specific observe, for this specific things, general purpose OS is not required. Yes, precise OS, particular OS is required, which way only few things will be enabled. Application specific, we can say. Now tell me, in my embedded product, if Wi-Fi is not there, so there is no requirement of Wi-Fi drivers. Will you agree? In my embedded product, if there is no Wi-Fi is there, so there is no requirement of Wi-Fi programs, Wi-Fi applications. So what we can do, we can disable them. When we are configuring the Linux OS, we can disable them. So that is the main benefit. That is the main benefit of this embedded. Yes, definitely cost will be reduced. Now, suppose if I am taking the help of licensed OS, if we take an example here, if this person, when he is developing this embedded product, if he is taking the licensed OS, proprietaryship OS, can I say the product cost will be increases? At last, the product cost will be increases. Why? Answer is, for every license you need to pay something to that third party. Yes, sir. And we can't modify it also. If you take a licensed OS, you can't modify it also. You means you think with respect to, you have the startup company, You're designing one embedded product with less cost you need to release into the market with high performance. So if you take a third party OS, what happens is, so just for every product for license you need to pay, and you can't modify it also, and final product cost also increases. That is the main reason why the Linux is becoming a popular. I'll agree, all of you may know other operating systems, but so embedded point of view, if you think it, Linux is better compared to the all others are having a graphical interface, some user friendly interface, but those things also can be performed here. And one more thing is better community support. One more thing is better community support. One of your friend D2 is asking one interesting question. So if so much advantage is there in Linux, so why you are not using a Linux OS in your system? Again, one of your friend is asking one question. If so much advantages are there in your in Linux, so why you are not using a Linux OS in your system? One thing I need to tell you, D2, this is the OS which is pre-installed, and graphically this Linux OS may not be that much effective. Graphically, like how I am using these things. And one more thing I need to tell you, within a few days, for Linux system programming, I'm going to use pure Linux system, because some of the features are not there in this whatever the some of the features are not there in this whatever we are using in this app. And also, you know that at this time, if any problem comes in my OS, so there is a difficulty. Network admin is not there. I'm not that much comfortable with the installation and all other things. So that is the reason I'm continuing with this. Yes, you can change it. But if I change it, entire classes, entire thing is going to be disturbed. That is the reason I'm not disturbing this at all. Okay then. So better community support. So R3 is asking why Linux is a virus free. So my question, my answer to R3, you can't understand at this stage the low level things. So better when the time comes, we'll discuss it. Permissions, security, so many things we need to discuss it. At that time, you'll get it. Okay. Now the discussion is, what are the components of OS? What are the components of OS? I can say mainly there are community support means, better community support means, observe, what is the meaning of better community support? Observe, when I am developing one my device and I've selected the Linux OS, I'm getting some problem, some bug. So it is a open forums are there. You can post your problem into that. So huge community, yes, big community is there. So you can join into that community, and what you can do, you can tell your problem. You may get an answer also. But if you are taking the license third party OS, just you need to say the problem. They will fix it. For that again they will charge it. So there is a big community support in a Linux for Linux. That is the reason day by day the Linux operating system is, and Linux is having so many flavors. On the top of the kernel, at the top of the kernel, so there are so many things will be there. You can add some features. I don't know how many of you know it or not. Mac is also low level kernel is a Linux only. On the top of that, they added so many GUIs, they added so many securities more than whatever it is having. Others additional features, they introduced it. Red Hat Linux, SUSE Linux, Fedora, CentOS, Ubuntu, Everyone has its own significance. I don't know you know it or not. A Red Hat Linux free versions will be there, licensed versions will be there. Red Hat Linux, Android is also a Linux, correct? When you go for a Red Hat Linux, free versions will be there and licensed versions will be there. Licensed versions you need to pay. Is it clear? So what you can do is, first you can give that product, that OS to free. After that you can, depends upon the demand, you can make the charges also. All these things are there. There are so many reasons are there. One of your friend is asking, sir, if Linux is then Ubuntu, Red Hat, SUSE, and all other flavors are same company or different? Different. You can release, you can download the Linux kernel, you can add some features, you can add some features, you can release with your name also on OS. You need to sign one agreement, GPL, General Public License. No need to pay for this. So like this, there are so many things at this stage, little bit difficult to understand it. Now, let's come to this. What are the components of an operating system? There are two components of an operating system. One is applications and another one is the services. There are major two components of operating system. If I draw the operating system, if suppose this is an operating system, suppose this box is an operating system. This operating system contains two components majorly. So one is called as the applications and another one is the services. Now tell me, user uses what? User uses what? User uses the applications. Applications need services. Again, user uses the applications. Applications internally communicates with the services. I'll write it. Just a minute. User uses the applications. Applications need, this is applications. Applications need services. All these services combinedly called as a kernel. All these major services are called as a kernel. Kernel is nothing but core of an operating system, core of OS. Like process manager will be there, like memory manager will be there, like file manager will be there, like network manager will be there, like signal manager will be there, like thread manager will be there. Like this, all the major components, major parts in a Linux, those are kernel. Kernel is nothing but a core of an operating system. What user will do? User uses the applications. User uses the applications. Applications internally need a services. Now, if you take an example, whatever the data I written here, can I say this is one application? Can I say this is one application? Now, for what purpose I am using this application? Can you tell me for what purpose I am using this application? To save some data. Will you agree? For what purpose I am using this application? To permanently storage. Now, can I say this applications internally communicates with the file manager, because file manager is responsible for managing the hard disk. Memory manager is responsible for managing the RAM. Network manager is responsible for managing the network devices. Signal manager is managing, like every manager is responsible for managing some resources. All of you are getting the point, whatever the discussion is happening. If you're getting the point, please type 1. All of you are getting this point. So operating system contains major two components. Operating system contains major two components. One is called as applications and another one is the services. Observe, user uses the applications and applications need a services. Observe this point. User uses the applications and applications need a services. One of your friend is asking, how is the communication between the kernel and applications? That's what the system programming. Again, how the communication is going on between these applications and the kernel. Kernel means OS, main part of an OS. That is nothing but the system programming. That is nothing but we are going to discuss in a future. System calls. Yes, correct. Using some functions, using some system calls, we need to communicate with the process manager, memory manager, file manager, network manager. Now, will you agree? Applications are optional, services are mandatory. The services are mandatory. Applications are optional. Will you agree? Services are mandatory. Now tell me, I'm using this application for what purpose? I'm using this application for what purpose? For browsing in internet. Hmm? Will you accept this statement? I'm using this application for browsing in internet. Yes or no? Please. Huh? Now tell me, if this application is not there, can I use any other application to browse on internet? Is there any other applications are there available? If I don't have this application in my laptop, can I use any other for browsing in internet? Yes. What is that? I can use this. I can use some other Mozilla Firefox like this. There are so many other applications are there. But suppose I have so many applications in my system, but network manager is not there. Internet is not there. Can I say there is no use of these applications? Can I say there is no use of these applications? Will you agree? In your mobile phone nowadays, around 80% of the applications need an internet service. Nowadays, your mobile phone, around 70 to 80% of the applications need an internet service. Suppose internet service is not there, network manager is not there. Can I say there is no use of those applications? That is the reason I am saying applications are optional. If one application is not there, another application you can. Services are mandatory. If service is not there, there is no use of application. Suppose there is no file manager is there. There is no use of notepad, wordpad, paint or whatever it is, because all these things, if you want to save, the file will be present in the hard disk. It is going to be saved in a hard disk. But if this file manager is not there, if this file manager is not there, can I say there is no use of those applications? I hope with these examples you got applications are optional. Applications are optional, services are mandatory. All services are combinedly called as all services are combinedly called as all services are combinedly called as a kernel, core of an operating system. Now, one thing I need to ask you, in your mobile phone, now when you install the new application, do you need to restart your system, your mobile phone? No. You can install, you can uninstall. There are so many things you can do easily, like a plug and play. Now tell me, when the new version came in your mobile, you may get a notification also. Please try to update a new version of OS. Now will you agree it will take some time? And also it will ask you to reboot, restart. Now tell me, now when the new OS will came means, can I say new kernel came? Maybe in a previous, some maybe small bugs will be there that may be fixed. And all of you need to, in your mobile phone, which kernel version is there, which kernel is there, you need to find out. Is it possible? In your laptop, in your what you called, in your mobile phone, It is possible. You can go to the setting software somewhere, what you call mobile configuration somewhere. You will find out which kernel version is there. And also you may know that when you purchase a new mobile, some of the applications will come default. Some of the applications will come default. And some of the applications later you can install it. Will you accept this statement? Some of the applications later will you can install it. So is going to use user is going to use yes, one of your friend is asking, sir, if there is no storage, if I'm trying to download any application, no storage message will come. This is because of this file manager. Again, I'm saying you, it's for me, it is not possible in a single day to imagine all this thing, to make you to imagine all these things in a single day. One by one, daily, definitely you'll get some idea internally what happens. So kernel is nothing but a core of an operating system. User is going to use an applications. Applications need a user is going to use an applications. Applications need a services. And one of your friend messaged, sir, in my mobile 3.1 18.24 kernel version. And another student, there are so many messages I am getting the kernel version. Kernel is nothing but a core of an operating system. All the managers, core team, all the managers are called as a kernel, like a process in a simple way: process manager, file manager, network manager, signal manager, thread manager. Some of the drivers are also called as. Now tell me, uh, suppose there is one in my pen drive, one song is there. I need to listen the song. Take an example. In my in one pen drive, one song is there. I need to listen the song through my laptop. What should I do? First job. Will you agree? I need to insert the pen drive to my mobile, my laptop. Yes or no? Attach. After that, I required some applications. Yes, permission is there. Everything is there. I need some applications. Yes or no? There are so many media players are there. Will you agree? There are so many media players are there to listen the song. Suppose in my laptop, audio video drivers are not there. All the devices are there. All the devices are there, but audio video driver is not there. Can I say there is no use of those applications? Hmm? I have a Wi-Fi. I have the wired Ethernet port. I connected the wire or Wi-Fi. I connected to router. But without an internet service, you can't do anything. Our Wi-Fi driver should be installed. Yes or no? Previous days, you might have know this. In a previous days, when you plug in, suppose you connect, you taken a new printer. When you taken a new printer, when you connect it, so you need to install some drivers. Like you need to install some drivers. You need to download. Previous days, what we used to do is, so when we purchase it, they will provide a what you called a CD. Through CD, we need to install the drivers. Then only I can use it. Small CD they will give us. But nowadays, smart embedded products are coming. When you insert the device, automatically, when you insert the device, automatically it will check the driver is there or not. Will you agree? Automatically, it will check the driver is there or not. If not there, it will ask and automatically it will install. A18 is asking, below the kernel, there is a see kernel. In this kernel, I can say in this also some drivers will be there. Again, device drivers are there are two categories. Again, there are device drivers we can say in two categories. One is running on the top of the OS, another one is running on the hardware. Again, when you go for device drivers again two things. One is running on the top of the OS and another thing is on the top of the hardware. Drivers I can say in another way, in this kernel only drivers will be there, all the services. Will you agree A18 drivers are services, applications using those drivers? A18, yes. So if that is the case, it is a part of the kernel, it is a part of the OS. One thing I need to tell you, some of the services automatically when you install the OS it will come. Some of the services will not come. Explicitly you need to load it like an applications. Some of the services automatically it will come. Some of the services when you required you need to load it like if you take an example, printer, you need to explicitly load it, the printer services, like external webcam you connected. Yes, drivers are added to the kernel, correct. In a kernel space, I need to tell you one more thing. RAM is divided into two parts. RAM is divided into two parts, applications and services. Kernel, user space and kernel space. Getting the point? RAM is divided into two parts. One is a user space and a kernel space. All these applications are running. Can you imagine all these applications runs in? All these applications runs in applications runs in which space? User space or kernel space? User space. Now, who is there in a kernel space? Who is there in a kernel space? OS will be there. OS means what? Kernel. Kernel means what? All the managers, all the services. Got a little bit idea? Got a little bit idea? Some of the services, when you install the OS, automatically it will come. Like how the sections are divided, definitely. So it is called partition. When your OS is loaded, automatically the partitioning is done. And one thing I need to tell you, our module name is Linux system programming. Some of the things we cannot discuss here. One of your friend is asking how the partitions are, how the sections are divided. That is not the part of this module discussion. I hope you are getting this point. What are the two parts in a kernel space? In a kernel space, no, there is no such two parts. RAM is divided into two parts. One is a user space and another one the kernel space. In the kernel space, all the managers are there. In a user space, your applications are running. Is it clear? In a kernel space, all the services are running, all the managers are running. In a user space, all our applications are running. Now, will you agree these services should run continuously when the OS is loaded? What is the meaning of OS is loaded means? Can I say all these managers are started running? But applications, when you require, you double click it, then it will start running. Applications continuously will not run when your OS is loaded. Will you agree? Applications will not run continuously in a RAM when your OS is loaded. But services continuously runs. Applications, whenever you want, you can double click it, you can start using it. You means again, you means user. Background services, front end applications. We can say background services, front end applications. Now again, you need to understand background process, foreground process. There are so many things are there. In a single day, it is not possible. I hope this is clear. There are two major components of an operating system. One is applications and another is the services. Next thing is booting steps of Linux OS. What is the meaning of booting steps of Linux OS? When you switch on the system, till you switch off the system, when you switch on the system, till your login screen comes, what are the works background it is taking? Will you agree? It will take some time to use this your laptop, or when you switch on your mobile phone, it will take some time to use your mobile phone. So what happening behind ever since? Those are nothing but a booting steps. From the moment you switch on your Linux system till the login screen comes, internally there are 6 steps takes place. The first step is BIOS. Have you heard this term? BIOS. The first program which started executing called as a BIOS. When you switch on the system, the first program started executing is a BIOS, which is present in the ROM chip, ROM. The manufacturers of your motherboard, listen the statement very carefully. The manufacturers of your motherboard will burn one program into the ROM chip that is called as a BIOS program. A basic input and output system. You may get it out, sir. Program means it should. T2 is asking what is your motherboard. Please try to search in the Google. Please try to search in the Google what is a motherboard, heart of your system. We'll see what is MBR, what is a grub, what is a kernel, everything we need to discuss it. Wait. K4. Wait. So the first part, when you switch on the system, the first program starts executing. That is called as a BIOS program. CPU, you can say. Yes, A18, you can say. Motherboard, you can say as a CPU. BIOS stands for Basic Input and Output System. Perform some system integrity checks. System integrity checks means it will check all the things are properly, all the hardwares are properly working or not. I don't know. Some of you may, if those who are using the desktop, not a laptop, desktop, you may get a booting error. You may get a booting error. Then what you will do? You will open the CPU. In the CPU, maybe the RAM is not properly inserted, or maybe hard disk connector may be loose. So what you will do? You will clean it and again you will put it. Then it will start booting. Listen. So what the BIOS program will do is it will basic integrity checks. It will do. What is the meaning of basic integrity checks? Means what are the basic hardwares required? What are the hardwares which is must and should required? So those hardwares are connected properly or not? It will check. Like RAM, like hard disk. So some of the hardware components are required. Those are properly connected or not? It will check. You make it a doubt, sir. How it will check? Simple question arises in your mind. So how it will check? Further, there is a lengthy processor will be there. They will send some signals. They will wait for the reply. If they got a reply, meaning is that device is connected properly. Got the point? So the step number one is a BIOS. BIOS is stands for basic input output. It performs some integrity checkings. I don't know how many of you know when you press just handshaking signals, you can say. How many of you know it? Like when you press some delete button, BIOS settings will come. When you switch on and when you press some delete button or some F1, F2, something one button is there. When you press it, so BIOS settings will come. Where? escape button, whatever, F12. Depends. Different keys will be there. So what happens there? BIOS settings will come. You can enable, you can disable the pen drive. You can set a password, and you can check the booting priority also. Configuring, yes, booting priority means from where operating system should be loaded. That is going to be checked, configured. Like this, this is the first program. When you switch on the system, it will start. Where it is present? In a RAM or in a ROM? Tell me where it is present. It is present in a ROM, and it will search, loads, executes the bootloader. It will search, loads, and execute the bootloader. I don't know how many of you know it or not. You can make your pen drive as a bootable device. Normally, hard disk is a bootable device. In a hard disk, only OS will be there. Instead of hard disk, you can change the settings in a BIOS where instead of hard disk operating system is loaded, you can load from your pen drive also. Those settings you can do it. Those things you can do it in this BIOS settings. Yes, by burning ISO image, correct. During the BIOS startup to change the booting sequence also. Now what is the bootloader? Wait, D2, please wait. All these things we need to discuss. MBR, grub is a loader. So tomorrow what we'll do, we'll discuss these things, because within this time I can't finish it. BIOS is separate. Yes, BIOS is present in the ROM chip. In this step, OS involvement is not there. Here, OS involvement is not there. Here is not there. Here, from this step onwards, the OS will come. OS is loaded here. Got the point? OS is loaded here. 1, 2, 3, fourth. Who will load? Grub loader will load. We'll see. Tomorrow we'll discuss step by step, point by point, but not in detail. In detail discussion cannot be possible at this moment. In a simple way, we need to. A9 still not decided. Don't worry about it. Okay, I'm going to stop the discussion. So tomorrow we'll continue the things. Tomorrow booting steps, and after that process and process management. There are so many things we need to discuss. I'm going to stop the discussion. Thank you very much. This PDF already shared. This PDF already shared in the Linux. Please, in the last lecture only I told you. Thank you.